Hey, welcome back to Overthinking Tech. This is my second time filming this video. First time took way too long. I'm going to try to go faster. That probably will just mean that I'm talking more. Also, I apologize for the light hitting me in the face. The sun is managing to get right between the gap in my blinds. There's unfortunately not much I can do about it besides wait for the sun to move. So, I definitely overthought a problem I had. I think it's a fairly common problem for a lot of people to have, which is that I have a lot of photos, like decades of digital photos just sitting in some folder marked pictures that has been backed up but has not in any way been sorted because who has the time? Now, there's paid solutions out there for software that will sort photos, and that's great and all, but basically I code for a living. So I just thought, well, make my own. And that's exactly what I did. I made a Python script that sorts photos by month and year. And this is going to be a pretty boring video. I'm just going to walk through the script. If you're interested in how to sort photos, how existing algorithms do it, how I did it, then keep watching. If you have no interest at all in seeing my solution for photo storage, then this is definitely not the video for you. It's going to be very boring, even by my standards, because it's just looking at some Python code. But here we go. So, as I said last time I tried filming this, took way too long. I'm just going to jump in. First thing I do, bunch of imports. I do need to make special note of this PyHEIF import because it's commented out here. And the reason it's commented out is because I'm currently on my Windows PC and PyHEIF does not have a Windows compatible version. It is compatible with Linux and with Mac OS. The reason I have it here is because iPhones and iPads use a Apple-only file format that by default Windows can't even open to view an image, and it's not compatible with the Pillow library that I'm using for the rest of the images. It needs its own special library just to open and manage. I do have that working. However, because I'm doing this on a Windows PC and it's not running on my Unraid server, where normally I run this script, I can't actually import that right now, so it's commented out. Everything else here is pretty standard. Print statement for starting. I like print statements, so I know what code's doing when it runs. Really simple setup for how to actually back up your photos. Once you have the script, once it's working, the backup location, this is where things are going to get backed up to. It's also the sorted location. Everything backed up there will be sorted by month and year. And then the location of the not sorted stuff, or the stuff that needs to get backed up. I created a test directory that I will open up and we can look at and actually test the script on. The first function in this script is my compare function. This has three separate outputs, 1, 2, and 3. Output 2 is a do nothing output. This is what occurs if the file that you want to move already has a copy at the destination that is exactly the same as the copy that you're looking to back up. So we just skip it because why waste time on it? We'll get into what output 3 does. It actually gets used in a separate function later down. Output 1 is if I'm trying to back up a file to my backup location and there is no matching file at the backup location. Obviously, if that's the case, I want to move that file there. I called that compare. It literally is designed to look at two files and compare if they're the same or not. How am I doing that? Two methods, and it depends on the file type. Method one, even though it's second on here, is to open two image files and compare the contents of the images and make sure they're the same. Method two is to hash the first 32 kilobytes of the file and compare their hashes. If you're trying to compare video files, opening the full thing and doing a full comparison can take a really long time. That's why I have this thing called video extensions. There's actually some image files like the Apple ones that I mentioned earlier that I can't open the images fully for, so I just hash the files and compare that. Generally, I would say it's ideal to compare the actual data in the images. Where that's not doable, this hashing is a very competent second option. In the event that those two images are the same, that's where we return this 2. And we say, hey, the image I'm looking to back up has already been backed up. There's an exact copy of it there. I don't need to back it up again. I can skip it. 3 is, hey, I have these two images. They have the same file name. They're going to be backed up to the same folder, but they're different images. What do I do? We'll get into what actually happens with that in a later script, but this function outputs just the number 3 for that. Next on the list is this hash function. Really, really simple. It loads the first, what am I doing here? 64 kilobytes and hashes it so that we can compare the hash strings. It just returns the hash string. Super simple. Get month takes a numeric input, outputs the string of the month. I am like positive someone else wrote a function to do this. It took me less time to write my own function than to find someone else's function. So I just wrote my own function to return the name of a month based on the number of a month. Then we have get date. Oh no, I have an error. I have a library that isn't defined because I commented it out. To compensate for that, I'm actually going to comment out this entire block right now. Oh no, on the fly code edits. I had special code written for specifically those Apple file formats, and the test set I have does not include any .heic files, so we won't encounter that case. If you have photos taken on an iPhone or iPad, you will need to account for how those are being handled. For the moment, we can just skip that mostly. I'll still talk about exactly what I have that code doing, though. So getDate is designed to basically do just what its name says. I want the date a photo was taken, not the date it was last edited, not the date it was last opened, not the date it was imported onto a computer. I want the date the digital camera that took that photo actually took the photo. Because for me, at least, that's how I remember events. If I want to go back and look at photos from high school someday in the future, not sure why anyone wants to revisit high school, but if you do, most of us know what years we went to high school. So going back and looking and saying, hey, I was in high school back in 2012. Let me go look at that year. I know I just made some of you feel really old. I actually was in high school in 2012 and some years after that as well. That's just a really easy way to sort things. So having that date taken, for me, was sort of my gold standard for how do I sort photos. So there's a couple ways to do this. All of them involve metadata. Now this can get screwed up if metadata is lost. In which case, the best we can do is the last date modified, which is going to be on any photo regardless. If you have it saved to a computer, it has a date modified attached to it. However, ideally, we would use metadata. Now, I have this written as a try and except function, because if it fails to get the metadata or if it doesn't exist, it will return an error message. And in the event you get an error message, you need to basically catch that and prevent the program from crashing. Go to the accept. Right now, the accept, because I commented out some of this, is just looking at the get time from the operating system path, get time function of that file. That's the last time it was modified. That is like our worst case scenario, not really what we want. That's why the .heic stuff even happens first. Now for a standard image file, there's two tags that I have found date taken can get stored to. The documentation for Pillow actually only pointed to this first tag. This second tag seems to have been used on some old digital cameras that I encountered and I had photos from. Anything modern seems to use this first one. I grab both and I check them. I do check for a specific case. The old stuff that didn't use the first tag always had that year set to 0000. I don't want to actually... So if you hear a cat meowing, he has some separation anxiety. He meows a lot. He's fine. I don't actually want to count years 0000. Nothing happened in my life in year 0. But I do otherwise, with the exception that 1 year, want whichever year is smallest. So I compare this temp 1 and temp 2, and if temp 2 is smaller, or if temp 1 is year 0, I use temp 2 and I output it to temp. Otherwise, I use temp 1. That means I always get whichever year or date is the smallest. In this case, I'm just comparing years. In theory, there could be a month that's earlier, and I could mess up months, but this is still pretty good. I take that string, I grab the first 4 characters for the year, and then I grab these characters, 2 characters from that for the month. Those are saved as a string, so I do have to use the int command here around that to convert the string to an integer to pass to my function. I could have written these as strings instead of integers from a comparison point, but whatever. I do include the string number in front of the month. Undo that drag I just did. We'll see that when we actually sort the photos. The reason for that is Windows liked putting April first because it alphabetically came first when I opened a folder, and that was unbearable. January comes first because it now starts with 01. It's just better. HEIC is a pretty similar thing, with the exception that I can't check for a specific tag associated with a date. So what I actually do instead is I load in the metadata as one continuous string. So here, this just turns the metadata into a string. I then look from 1970 to the year 2100, and I just say, if there is part of this string that matches, the year 2004, I'm betting that that is the year, and that is the part of the string that starts the beginning of the date. So far, that has worked flawlessly for me. I look for part of the string that it does exactly match a year between 1970 and 2100, and I assume that that is the year the photo was taken, and the characters right after that are the month. That's worked perfectly. Again, I end up getting the same output of a year as a 4-character string and a month as a 2-character string. I can push that through my get month and combine them the same way I did before. And then once again, if none of that works, we can just get when it was modified last. Kind of worst case scenario. My output here is a string that is structured with the year and the month as separate folders, separated here by the Windows folder separator for the sake of running this on Windows right now. And that'll be the folder it gets saved in. Inside the sorted folder, we will have folders of years and then subfolders of months, and every photo will be in the accompanying month and year. I have video extensions and file extensions. I keep video extensions separate for the reason I said above about hashing versus opening. Obviously, not all of these are actually video extensions. PDF isn't. Weirdly, I had some PDFs saved into my photos folder that kind of did constitute being photos, even though they were .pdfs and were PDFs, not JPEGs or anything. I still wanted to back them up, compare them, so I'm just hashing them. If they're photo formats I can actually open, then we do that instead of hashing. I do have this exclude list. Anything in this list, if these strings are present in the file name, they'll be excluded. This is mostly because of like temporary files that programs make and then don't properly clean up, or in some cases like these .json files are like weird metadata files that some programs make about photos that I just didn't want. So I exclude them. I don't copy them over. Then I have this file checker. So this is what actually takes a source file, the accompanying what that file would be at the backup location, and the extensions, and actually does the moving of it. And we can do either move or copy. I have both listed here. Depending on what I'm doing, I'll sometimes switch if I actually want stuff moved or just copied. For right now, we'll do move because it'll show off what a later function can do. We compare them. This is the comparison function I showed you earlier with outputs 1, 2, or 3. We grab those outputs. If it's output 1, that's, hey, I want to back up file A. There is no match in file A at my source. Let's move that file. We make the directory to ensure that the directory that we need the file backed up into exists. And then we go ahead and we move it. If a file exists at the source that exactly matches our destination, that's case 2. We don't need to move the file. I just remove the file from the source. Again, normally if I'm copying files instead of moving them, I won't delete files at the source either. However, in this case, let's delete it. Let's not bother copying the data because that takes time. Deleting it's faster, so let's just delete it. Event 3. This is the event where I have a file at my source and I have a file at my destination with the same name that's in the same year folder, that's in the same month folder, but they're different files. Either I opened the images and the images were different, or the hashes were different. What do I do with those? Well, I add other to the end of one of them. I just take its file name and I put other at the end, and then I run the script again. I run it recursively, file checker, so that, say I had 3 photos that were all different, but were all taken the same month and had the same name. I would end up with one that has the original name, one that has one other added to the end, and one with 2 others added to the end. I just keep sticking others at the end until it's a unique file name. It works. I don't think I've ever seen 2 others. I don't think that has occurred within my photo library, but if it did come up, you wouldn't have an issue. Okay, % done, temporary %, length of the list. This is all done so I can print out % by % how far along the program is. They're just standard print statements in Python, but this basically acts like my progress bar so I can know things are progressing. It's not perfect. If files are bigger than, like, say I have like a 100 gigabyte video file or something ridiculous, and then 1 gigabyte of photos, that single really big file counts exactly the same as like a standard 3 megabyte photo file. It's just of the total number of files present, what percentage of them have you walked through? It's reasonable. Round it because I don't need percents out to 8 decimal points or whatever. Now the for loops. Locations is the list of backup locations. I didn't mention this earlier, but you can actually list multiple source locations that you want all backed up to one backup location. So we'll just iterate through those. We'll iterate through all of the files and directories and their subdirectories as deep as we need to go. We'll look at every file within a folder. We'll check to make sure it has one of our extensions we care about. We'll also check to make sure it doesn't have one of the excludes we don't want. Then we go ahead. This is just designed to make sure the string structure for backup location is correct. So the folder it's in, the file name attached to that folder, go to our backup location and then add that date taken, add the year and the month so that it makes those folders. And then add the file name to the file location so that we have the correct file name attached to it. Pass both of those through to our file checker, which we already looked at. Based on how many files were in that folder, we're going to update the percent. I only print if percent has changed by more than 3% of the previous print, so we don't get ridiculously long. At most, we'll get 33 or 34% print outputs. The last thing I said, and the reason I'm moving files and taking the time to delete duplicates, is because I wrote this little folder remover script that goes in and deletes folders that are empty. It also automatically removes some things like thumbs.db files because they're technically like a system file or a thumbnail file. I'm not sure. Desktop.ini is a system file. It's not needed. They ended up in my folder library because a lot of folders were literally like, okay, someone's got this old computer that is probably got a failing hard drive in it. I'm just going to copy their user directory over. I moved the picture folder into all my other picture files. It's got some other stuff in it that isn't just pictures. This won't delete everything. These were the most common files I encountered that I could get the script to delete, so I didn't have to deal with a bunch of extra folders. In the event it tries to remove a folder that it does not have permission to remove, it normally throws an error message. I use a try except again so that it can print access denied and just tell me what folder it couldn't remove because it didn't have permission to. I actually run that a couple of times because it's not perfect at removing every subdirectory. Running it a couple of times makes sure that things are actually deleted. Hopefully, sometimes that isn't even enough times to run it, and you just have to do things manually. But it's pretty good. You have a lot of subfolders. It's pretty decent. So let's take a look at these example sets then. I have one folder here, not sorted. That is the folder we originally, or I should say I originally pointed everything at. Oh, actually, hang on. You guys can't see. Not sorted. There you go. Now you can see it. So we have this not sorted folder. Inside of that, I just grabbed a bunch of photos. There's a pit bull and a burrito. These are just photos I had in my library. These all have metadata attached to them. We can actually see when hovering over them the date taken. At least I think you guys can see that as well, right? Oh, you cannot. Interesting. OBS doesn't capture that. When hovering over photos in Windows, Windows gives you a little pop-up that has additional information, and that includes size, dimensions, image type, and the date it was taken. You guys aren't seeing that pop-up. It does show the date photos are taken, which is actually the date we want to pull out of the metadata with our Python script. So it's attached. The metadata is there. I also have these rando folders. I've got some duplicates. I've got some not duplicates within this folder. Some of these are unique photos. Others are not unique photos. I have a second random folder. Some of these are duplicates again. I have a second copy of that first random folder inside of the second random folder with some duplicates and some different photos. The point is, this is a mess. Weirdly, maybe I'm alone in this. This is what my photo directories looked like. But I want to fix them. So we can bounce back. Oh, wrong button. We can bounce back All I have to do is click F5. We're going to get our percent output. This isn't very many photos, so it won't take that long. Okay, so the script finished running. Let's take a look at what we have in our folder now. We no longer have a not sorted folder. It's gone. It's been removed. It was completely deleted. I don't like having to go back in and manually delete folders. So it's really nice that there's a script that checks to make sure they're empty and then removes them for me. It does make sure they're empty. I don't know if I mentioned that. It makes certain they're empty. So if there's folders remaining, I know I should check those folders to see if they're empty or not. But if it's been deleted, it was empty. Inside our sorted folder, we have years, 2020 and 2021, and inside those we have months. We can open up a month. We can see we have all unique photos with their original name. We still have metadata on them. We can go to details and we can see that date taken metadata. We can see, looks like this was taken on an LG V40 phone. I had that phone for a while. All that great metadata is all right there. We've gotten rid of none of that so we can keep sorting things in the future. You don't want to delete metadata and screw yourself over next time you reinvent a sorting algorithm, if you're like me and you do that. But look, jack-o'-lanterns in October, because that's exactly where they should be. No one's making those in July. So that's basically all I got. That's my Python script. I'm pretty excited about it. It's pretty awesome. IMO. Was there overthinking involved? Yes. Most people would not bother to do this. Most people, if they really cared, would buy a solution. But that's not what this channel's for. So I hope you enjoyed. Hopefully, if you actually watch that, you learned something. And because I'm making YouTube videos, I now have to do the obligatory please subscribe and like this video. Or don't. I'm not a partner with YouTube yet. I don't make money, so I don't actually care right now if you like and subscribe. But if you want to see more, like and subscribe.